Okay, so we're going to find a partial derivative in this problem using the chain rule for functions of more than one variable. We have z equals x to the fifth times the square root of y, and then x and y are given by these equations. And we want to find del z del t, so the partial derivative of z with respect to t. So let's talk about the formula and how to memorize it. So del z del t. So you want to think about how you can get to t. Well, there's two ways to get to t. One way is to get through through x. So you take the partial of z with respect to x times, and then the derivative of x with respect to t. So one way is to get to t through x. So going through x, we take the partial of z with respect to x times the derivative of the inside function, which is x, with respect to t. And plus, the other way is to go through y. So del z del y, and then times the derivative of the inside, so del y del t. So again, two ways to get to t. You can go through x or you can go through y. And note that x and y are both dependent on t, so that's the chain rule. So now del z del x, we just look at this and differentiate. Before we do, let's go ahead and write this like this. This might be more beneficial because when we take the partial with respect to y, we have a power there, so it might be easier to differentiate. So del z del x, when you're computing this, all the other variables are constants. That's true for any partial. When you're computing any partial with respect to a variable, all the other variables are constants. You want to treat them that way at least. So this, we're treating this as a constant. So it'll be 5x to the fourth square root of y. I'm going to put this in parentheses just so we can match it up, so we can check our work. Del x del t, it's the partial here with respect to t. Here it's going to be 0. Here it'll be 2t from the power rule. So simply 2t. Plus del z del y, so we're looking here, so it'll be 1/2, right? The x to the fifth is a constant. X to the fifth, y to the negative 1/2, just like that. Okay, so that would be del z del y. And then del y del t, we're taking the partial here with respect to t. This derivative is 0, so this will be negative 4t cubed. All right, good stuff. So this is equal to, so now we can multiply here. 5 times 2t is 10t. And we can replace all of the x's and y's with what they are. So here's our x, here's our y. So s to the fourth plus t squared. So I'm going to put that here for the x. S to the fourth plus t squared to the fourth. And then we have the square root of y. So square root s squared minus t to the fourth. Just replacing y and replacing x. Everything looks okay. It's really easy to mess up, so it's really important to be careful. Here, the 2 and the negative 4 cancel, so we're going to get a minus 2t cubed x, so it's going to be s to the fourth plus t squared to the fifth. Okay, that's our x. And then this is going to come downstairs and turn into a square root. So square root s squared minus t to the fourth. Okay, and that is pretty much it, right? That would be the final answer in this particular problem. So we have found the partial derivative with respect to t of this multivariable function. Good luck.